Welcome back to Math with Ace, focusing on statistics. We are ending our exploration of linear regression. In this video, we're going to talk about residual plots. We're going to talk about what a residual is, how you can make a prediction and calculate a residual, and what sort of information you can expect from your graphs. First of all, it's important to remember that when you are talking about predictions, you should not be predicting outside of your explanatory variable range. So your X values, you should not be predicting outside of that. We talked a little bit more about that in the previous video, but notice that our X value goes up into about 145,000. So if we predict over 145,000, we do not know that the model follows this path still. And so it's really important that we stay away from making an extrapolation, which is making a prediction outside your data range. Don't do it. Just bad. Okay. Now, we can make a prediction using our regression equation. So again, in Staplet, we went and did two quantitative variables. We entered our data that you've seen up here. You can see I entered two quantitative variables. I called it miles driven and price, and then I inputted the numbers that came from the table above. And then I began my analysis, and I was able to get a scatter plot, which does not have the line of best fit at first. You need to then calculate the least squares regression line, which just means you click the button that says calculate the least squares regression line. And once you do that, you get the line through the data that best fits, and you also get the equation with the coefficient of determination. You can press the calculate correlation button to get the R value, which is the coefficient, the correlation coefficient. But I also have this residual plot. Now, a residual plot is something that shows us whether our line is actually a good fit or not. And when you're trying to do, you can actually perform inference with linear regression. And when you do that, one of the conditions you have to check is that you have equal variances and that your residual plot does not have a pattern. So in this plot, you're not looking for a line, you're looking for there to be no pattern. Now, if you're using ChatGPT or something like that, you might hear the word heteroscedasticity. It's talking about like starting small and getting big. It has a funnel effect. We're not using that language. The language that we're using is equal variances, or our residual plot shows no pattern. That's what we're looking for right now. We're not leveling up, okay? And what you need is you need an equal number of points above and below that line of best fit. And what's happening is you have these values up here that are positive residuals. And then you have these values down here that are negative residuals. If you notice on the left-hand side, those are positive values, these are negative values. A positive and negative residual, what is a residual? So if you remember in the video where I was talking about drawing squares, I said you drew lines from the line of best fit to the data point. That's calculating the residual. The residual here is a distance, and it is the difference between your actual data point and your predicted line. So a residual is found by taking the actual minus the predicted. Now, this is positive when the actual value is larger. So positive values happen when the actual value is larger. What actual value? What am I talking about? I'm talking about the distance vertically, which means I'm talking about Y. I'm talking about price. The actual price for that Ford F-150 that has about 70,000 miles driven. What is the actual price? That's that point right here. This is the actual price. This is the predicted price. The line is what predicts the price. Now notice, in this case, the actual price is below the line because higher numbers are up top. The actual price is below, which means that that's actually going to be a negative residual. Okay, so negative values happen when the actual value is smaller than the prediction. I should say than the prediction. So where does the prediction come from? The prediction comes from the regression equation. And the actual value comes from the data set. Okay, so in this case, all of the values down here that are below the line are going to be negative residuals. All of the values that are above the line are going to be positive residuals. So these are positive and these are negative. Now, does that mean that the line is an overestimate or an underestimate? Negative residuals are actually overestimates. Okay, so negative are overestimates. Why is that? That's because the actual value is below the line. That means that the line is above and the line is overestimating what actually happened. Positive values are underestimates because the line is below the actual value. It's underestimating what should happen. I would write that on a piece of paper and have it with you so that you can make that connection. Positive residuals are underestimates, negative residuals are overestimates because you're talking about that predicted value. So in order to calculate a residual, we're talking about the y values. We need the actual y from a data set, and we need the predicted y from the equation, and then we subtract the two. Okay, so your residual, if you wanted to use notation, is found by taking the actual minus the predicted, because remember the hat means that you're predicting. And you can make predictions for any value in your data set, but in order to calculate a residual, it has to be an X that lives in your data set. So the only ones that I could use right now are any of the X's here. I can only calculate residuals for any of these X's because I don't have actual values for any of the other data. Okay, so let's pick one. Let's say I want to predict for 8,359 miles driven. What is the predicted price? I know that the actual price is $31,891. So I know the actual. What's my prediction? So let's write that down. So the actual price of a Ford F-150 that was driven, let's go back up, 8,359 miles is 31,891. Okay, so this is the miles driven, and this is the actual value. So this is my y. I need y hat. So I need to calculate this value, which means we need to substitute in the input. We need to plug in the miles here and use the order of operations to help us calculate that prediction. Let's go up to the graph really quickly and see what kind of image or what kind of residual we should get based on the picture. So 8359 is going to be, let me get rid of all this stuff here. So this would be about 10,000. I would say we have a 4, and then it's the next one. So I'm going to say that this is our 8359 miles, which means that the actual value should be below the prediction. So we should get a negative, but let's calculate. Let's plug in and see. So I'm going to take my equation here, and I'm going to take 35,314.06942. I'm not going to round anything just yet, minus 0.13966. And instead of X, I'm going to plug in my input of explanatory. So you take the X value that you're given to make a prediction, substitute it into the equation, and you perform the order of operations to simplify this equation. So we need to multiply first. The order of operations says we multiply before we subtract. So I'm going to do 0.13966 times 8359. And I get 1,167.41794. Again, I'm not rounding yet. You don't want to round until the end because you're cutting down your accuracy. So then I subtract 35314.06942. And I get 34,146.65148. Now, this is price, and your instructions might tell you to round to the nearest dollar, or you could round to the nearest cent, but we don't have anything that is less than pennies. So we could say that the prediction is 34,146.65. Okay? So we have our actual value and we have our predicted value. And in order to calculate our residual, we take the actual minus the predicted. $31,891 minus 34,146.65 gives us a residual of negative $2,255.65. So what that means is our line overestimated what the price would be. We did talk about the fact that there's other reasons why there might be variability. So it's not necessarily going to be a guaranteed spot on because the R value isn't 1. But the residual being negative means that our actual value was smaller than what our line was predicted to be. So if you go back up to the graph that I mentioned, that's saying that this distance right here is about $2,200, which makes sense in our scale because our scale goes from 10,000 to 40,000. Okay. So with your regression equation, you can determine how much the price should decrease for every additional mile driven, what the price is expected to be when we've driven no miles, how strong the relationship is between miles and price, how much variation in price can be explained by the relationship with miles driven. You can also determine whether this was a good fit or not using the residual plot. You can make predictions of, let's say I drove my car 90,000 miles. What can I expect to happen? And you can also calculate residuals to see how far off the line is. So those are all the things that you can do with the regression equation. It is very helpful, and a lot of people use it in the real world. Thanks for watching, y'all. Have a great day.